everything in cryptography has one basic principle, and that's called Kerckhoff's principle. So the idea is that crypto systems should remain secure even when the attacker knows all the internal details of the algorithm or the system. Okay, so all the algorithms we're going to learn are public. Everyone can see them. Everyone can see how to encrypt data, how to decrypt data. The only thing that's going to be secret are keys, and only certain keys. Okay? So it should be easy to change a key from time to time, but the algorithm stays the same. So first, what principle does this remind you of that David told you in software security? Does it remind you of any principle? Yeah. Yeah, the obscurity one. or the lack of obscurity, yes. So, exactly. So don't do security through obscurity. Right? You want your algorithm and the system to be known and public. So why? Why do you want that for encryption as well? Can you think of some reasons? Yes? Exactly. So the moment your algorithm is leaked, then of course all your data is becoming public. More than that, even the future is pretty terrible because you can't use that algorithm anymore, right? And maybe you spend so many resources trying to figure out what the algorithm should be investigating it, and now that it's leaked, you can't use it anymore. You have to go to a completely different algorithm, and that's not easy. Coming up with a new algorithm every time, it's super hard. Any other reasons? Yeah? Exactly. So it allows your algorithm to be evaluated by other people. There's a whole discipline called cryptanalysis, in which people try to attack encryption algorithms or cryptographic schemes to see if they can attack them and break them. And it's super useful to enable the whole world to do cryptanalysis, because then you can really trust an algorithm and build confidence in it. That's great. Any other reason why you might want the algorithm to be public? Yeah? Exactly. So you want other people to be able to use the same algorithm, but you don't want to share data with other people, right? You just want to share data with the people you're interested in sharing data with, but then you want a whole other group of people to also use the algorithm, and you shouldn't be able to tell, between these two groups who's sending what messages, right? So people should be able to use the same algorithm, but they choose their own keys. Okay, they have separate keys. Exactly, you guys came up with the same reasons that I had, namely that if your secrets are leaked, it's a lot easier to change the key than to replace the running software or to come up with a new algorithm. You want people to analyze and improve the algorithm, and you want multiple people from different trust models to share, to be able to use the same algorithm. So one of the early forms of encryption was with the Enigma machine, which in retrospect is a very, very, very weak encryption form. And while it doesn't obey the Kerckhoff principle, so not surprisingly, it's weak. But so how many of you heard of the Enigma machine? Great. Okay. The second question is, how many of you watched the movie Turing? Okay, so that kind of explains it as well. The Nazi Germany used to encrypt sensitive communication in World War II using the Enigma machine, and it was really, really helping them for a while. The way it was working is that it's electromechanical mechanism that scrambles the 26 letters of the alphabet. So you type in plain text, and it comes out scrambled ciphertext. But then if you take that ciphertext and you type it into a machine that's set and configured the same way, then it would output the plain text. And so for a while, this worked really well for the Germans, but then the opposing forces, the Polish, French, and English, and Turing played a major role, managed to reverse the algorithm. And this is believed to have actually ended the war earlier. Okay? And a big problem with this Enigma machine was that it was relying on security through obscurity, and once the algorithm was cracked, then you couldn't use these Enigma machines anymore.